Think about it for a second. Every person you've ever known, every song you've ever heard, every single thing that's ever happened in human history, it's all happened right here, on this one planet. But just how small are we in the grand cosmic scheme of things? Well, today, we're going to find out.
So let's just ask the big one, right out of the gate. How big is the universe really? It's a question so massive, it feels like our brains aren't even wired to answer it, but we're going to give it a shot. We're going to try to get a handle on the sheer scale of everything, one mind-bending step at a time.
Okay, so we're going to start close to home, in what you might call our cosmic backyard. Our very first step on this journey takes us to a pretty familiar sight in our night sky, the moon. I mean, when you look up at night, the moon just dominates, doesn't it? It feels so close, like you could almost just reach out and grab it. But the reality of that distance, well, that's a completely different story. So what's the actual number? On average, the moon is about 384,400 kilometers away. Now that's a number so big it's kind of meaningless on its own, right? So let's try to put that into perspective. And this visual just says it all. You could line up 30 planet Earths side by side and they would fit perfectly in the gap between us and the moon. Or think of it this way. If you got on a car and drove at a steady 100 kilometers an hour, it would take you 160 days, driving non-stop just to get there. That's what close looks like in space.
That distance means even light, the fastest thing there is, takes about 2.5 seconds for a round trip. Okay, now let's push out a little further, to Mars. When our rovers on Mars look back home, Earth is just a tiny little dot. And a message? That takes 20 minutes one way. So the first people who go to Mars will be nearly 1,000 times further from home than any human has ever been before.
But you know what? Even Mars is still just our next-door neighbor. To really feel the scale of our solar system, we have to go way, way farther. We're going to follow the path of the farthest object humanity has ever sent into space, the Voyager 1 probe. At these kinds of distances, kilometers just become useless. The numbers are too big, so we need a bigger ruler. And for that, scientists use something called the astronomical unit, or AU. It's simple. 1 AU is just the average distance from the Earth to the Sun.
So where's Voyager 1 right now? Get this. It's about 138 AU away from us. That means it's 138 times farther away from us than the Sun is. And here's the crazy part. Even after flying for over 40 years at 17 kilometers a second, it's still barely left our cosmic front porch. But from that incredible distance, it did something truly special. At the request of the amazing astronomer Carl Sagan, Mission Control turned its camera back towards home, and it took what might be the most profound and humbling photograph ever captured.
That tiny, pale blue dot, that's us. And honestly, no one has ever said it better than Carl Sagan himself. He said, "That's here, that's home, that's us." He reminded us that every human being who has ever lived, every king and peasant, every hero and coward, every single person in history lived out their entire lives right there, on a mote of dust suspended in a sunbeam.
Okay, I want you to hold on to that feeling, that humbling thought, because we're about to make an even bigger leap. We're leaving our solar system completely behind and heading out into the giant emptiness between the stars and galaxies.
So our old ruler, the AU, is just not going to cut it anymore. We need a new yardstick. This time, it's the light year, the incredible distance that light itself travels in one single year. We're talking about almost 9.5 trillion kilometers. This slide just blows my mind. You see that tiny little bubble? That represents how far all of humanity's radio broadcasts have ever traveled. Every TV show, every song, every message we've ever beamed into space is trapped inside that little dot. Beyond it, there's just silence. And this is all happening inside our own Milky Way galaxy, which is a staggering 100,000 light years across.
And our galaxy? It's just the beginning of our cosmic address. It's part of the Local Group, which is a collection of about 54 galaxies that stretches 10 million light years. And that group is just one tiny piece of the Virgo supercluster, which is just one part of the immense Laniakea supercluster, home to 100,000 other galaxies and stretching 520 million light years from one side to the other.
So we've gone from the moon to our home supercluster. Now it's time for the final leap, all the way to the very edge of everything we can possibly see.
And here we are. This is it, the observable universe. From one edge to the other, it's 93 billion light years across. Let that sink in for a minute. So what's inside this giant sphere? Oh, just at least 2 trillion individual galaxies. And altogether, they contain more stars than there are grains of sand on every single beach and desert on planet Earth. This edge isn't just a boundary in space, it's a boundary in time. The light from there has taken the entire age of the universe just to reach our eyes.
But here's the most important part. There's a reason we call it the observable universe. It's not the whole thing. It's just the part of the universe whose light has had enough time to get to us. It's our cosmic horizon. Which, of course, leads to the ultimate question, what's beyond that edge?
Well, one of the leading scientific ideas out there is the theory of cosmic inflation. And what it suggests is that our entire 93 billion light-year bubble, everything we can see, everything we've ever detected, is just a tiny microscopic fraction of the real whole universe.
How much larger? Well, this theory suggests the entire universe could be 150 sextillion times bigger than everything we can currently see. Just look at that number on the screen. It's 150 followed by 21 zeros. It's a number so huge our minds can't actually comprehend it. So let's try one last analogy. Imagine our entire observable universe with its 2 trillion galaxies and all those stars is shrunk down to the size of a single light bulb. If the theory of cosmic inflation is right, the entire universe, the whole shebang, would be a sphere larger than the former planet Pluto. We're all just living inside that tiny light bulb, with no idea about the Pluto-sized reality all around us.
It's truly humbling, isn't it? But being this small doesn't mean we're insignificant. Not at all. All it really means is that there is an almost infinite amount left out there for us to explore and to understand. So, if this is our reality, what's left to discover?